Hey guys, alright, so in this video I want to talk about uniform circular motion, how we can describe it, and what does the uniform circular motion actually represent, okay? What is it a term for? And then after that, I want to talk about unit conversions, and these units will be related to rotations. And then the last, I'll be showing you how you can apply these unit conversions, okay? Alright. So first things first, let's look at what uniform circular motion actually is. So uniform circular motion is actually a term that we use if an object is traveling in a circular path and this traveling of the object is happening at constant speed, right? So there's two terms, right, in that particular word, in that particular term, which is uniform and circular. So the word uniform here refers to the constant speed, and then circular refers to the circular path. Okay. All right. So how does it look like? Well, you have an object here, right? A blue dot, and then you have its path, and you can see that the path is circular, right, in shape. And how do we characterize this? Well, we characterize it by two variables. Number one, it is the size of the radius or the magnitude of the radius, how far it is from the midpoint or the center of the circle. And then we characterize it with the direction of that motion as well. So it can be anti-clockwise or it can be clockwise. All right. Okay, so that is all for uniform circular motion in that particular part, right? What it is about. It is about the object that travels in a circular path at constant speed. Okay. All right. So next, I want to talk about the unit conversion. So in when we talk about rotation, right, in real life, we will usually talk about how many rotation it makes in a second or in a minute, right? So generally what you can see is, for example, hard disk, right? Hard disk, they tell you, oh, it's rotating at certain RPM. Engines or tires, they work at certain RPMs, and so on and so forth. So the four units that you should be familiar with is number one, revolution. So we can talk about one revolution, and then we can talk about one rotation as well. So one revolution is the same as one rotation. And then we can talk about degrees, right? So one rotation is 360 degrees, right? And apart from those three, we can also talk about radians. And one rotation is approximately 2 pi radians. It is exactly 2 pi radians. I'm sorry about that. So based on this equality, right? Based on this statement, we can look at a question and then deduce what they are giving us, right? And deduce what they are asking from us and apply that to whatever problems that we have. So for example, let's say we have the relationship between degrees and radians, right? We have 360 degrees and then we have radians, so which is equals to 2 pi radians, right? So what we can do is we can divide both sides by 360, right? So what we have in the end is 1 degree is equals to 2 over 360 pi radians. Okay. Now, on the other hand, what we can also do is, so we have 360, we can do it on the other side, which is, so we have 2 pi radians. What we can do now is we can divide it with 2 pi, so 1 over 2 pi. And what we will have is 1 radian is equals to 360 over 2 pi degrees. Okay, so we can convert between degrees and radians based on what we divide it with and multiply it with, right? Okay, so let's practice that. So here's a practice question. The DVD rotates at a minimum rotation speed of 3,420 degrees per second and a maximum speed of 9,600 degrees per second. Calculate these values in radians per second. So I will do the first one, which is the minimum rotation speed, and let's have you do the second one, the maximum speed, right? So let me just demonstrate how you can do the first one. So I have 3,420 degrees per second. Now remembering that 360 degrees is equals to 2 pi radians, right? And they are giving us in degrees. So what I want to do is I want to divide that by 360. So I multiply it by 1 over 360. And what I will have is 1 degrees is equals to 2 over 360 pi radians. Now, since we have 3,420, I can take this statement or this equation and multiply that by 3,420. And what I will have is 3,420 degrees is equals to 2 times 3,420 degrees, uh, two, sorry, 2 times 3,420 over 360 pi radians. Okay, so 3,420 degrees is approximately 19 pi radians. Okay, now of course that is not what is given to us. What is given to us is 3,420 degrees per second. Okay, and that would equal to 19 pi radians. You know, you divide both sides by 1 second. Okay, right? What you get is 19 pi radians per second. Okay, so what we have in the end is 3,420 degrees per second is equals to 19 pi radians per second. Okay, so as an exercise, you can do for the 9,600 degrees per second, and that should give you, so 9,600 degrees per second should give you 53.3 pi radians per second. All the best in giving that a go, and I thank you for listening to this video. I'll see you in the next video where I discuss how you can apply, or how we will talk about centripetal acceleration, right, and centripetal force. Okay, so until the next video, thank you.